Okay, continuing with R coding. What is a list? In programming, it is common to want to work with collections of data. In Python, a list is one of the many built-in data structures that allows us to work with a collection of data in sequential order. Suppose we want to make a list of the heights of students in a class. Noel is 61 inches tall. Ava is 70 inches tall, Sam is 67 inches tall, Mia is 64 inches tall. In Python, we can create a variable called heights to store these integers into a list. Heights has assigned to it, and then in square brackets, 61, 70, 67, 64. Notice that a list begins and ends with square brackets. Each item is separated by a comma, and it's considered good practice to insert a space after each comma. But your code will run just fine if you forget that space. Let's write our own list. Examine the existing list heights in your code editor. So here it is. It says heights heights has assigned to it we have square brackets 61, 70, 67, 64. Notice how these are numbers, but they're not actually in ascending order. So we have 67, and then we go back to 64, and we have 61. So we do have 61, then 70, that's in ascending order, but then we go back to 67, which is below 70. Examine the existing list heights. That's the name of the list. Still a variable name, it's still a variable. A new student just joined the class. Chloe is 65 inches tall. Add Chloe's height to the end of the list heights. So we can use the add equals operator. Maybe it just wants us to put 65 like that. I was going to use the add equals operator. Okay, fine, that worked. Remove the hash character, the two lines crossed over one another, in front of the definition of the list broken heights. So I'm going to click delete. If you run this code, you'll get an error in your terminal, because here it says 65 space 71 space 59. So if we click run, we get this error. So it says file, and then in speech marks home workspace script.py, line 3 has an error. There's something missing here, so you can see we've got 5 circumflexes, 5 arrows, because we do need, we need 3 commas. So it's not the number of commas and the number of circumflexes correlated, but I put in 3, then I click run, and now we've got a tick. And that's everything, really. Congrats, you've exceeded your weekly target. You've done 5 days of coding. What can a list contain? Lists can contain more than just numbers. What is the definition of a list? It's quite interesting, this actually. Lists are mutable sequence data types used for storing a comma-separated collection of objects in a single variable. So lists are mutable sequence data types. Mutable meaning changeable. They can mutate. Let's revisit our classroom example with heights. So we have Noel, Ava, 70 inches, Sam and Mia. Instead of storing each student's height, we can make a list that contains their names. So we can say names, and we'll assign to that variable Noel in speech marks, comma, Ava, comma, Sam. We can even combine multiple data types in one list. For example, this list contains both a string and an integer, and that's fine. You might think that that's not allowed because you can't do concatenation with a string and a number. But no, you can have a list. You just can. You can have a string, so a bit of text in speech marks, then a comma, and then 61, the number. So this list contains both a string and an integer. Lists can contain any data type in Python. For example, this list contains a string, integer, a boolean, and a float. There's the float, meaning floating point number. Let's experiment with different data types in our own lists. Add any additional string to the end of the list, to the end of the list, which is called ints and strings. So here's a list. So I'm going to add on comma and then put cheese in speech marks. Now if I click run, nothing happens because we're not printing anything, we're not doing anything with that list, but at least we don't get an error. And I have a tick for that task now. Task 2. Create a new list called Sam, height and test score that contains 1. The string Sam to represent Sam's name, the number 67 to represent Sam's height, the float 85.5, and the boolean true to represent Sam's passing the test. Make sure to write the elements in exact order. Okay, so let's do that now. First of all, we need to create a list called Sam, height and test score. So Sam underscore height and test score. And I'm going to assign to it Sam, comma, 67, comma, 85.5, comma, and then true. Okay. So I've made sure there's commas sort of after each item. You shouldn't think of the comma as being attached before the item, so you don't think of it as comma 67 or as comma 85. It's almost like a sort of sealant that comes and closes the object. So it's Sam, comma, we're done with that now. 67, comma, we're done with that now. And it's a sealant that we only need if we know that there's going to be something after it. It's a bit like the dividers that people place down on the belt in supermarkets to say, look, these are my items, the person behind me in the queue, you can start putting your items now on. And of course, if you were alone in the supermarket, if it was a very quiet day and there was no one behind you, you wouldn't really bother putting a divider down on the checkout because you don't need to seal off your items from the person behind you. And in the same way, this true item here, we don't need to put a divider after it. It's just true with no comma after it. So yeah, even though there isn't always a comma after an item, because here we have true, there's no comma after it. Here we have cheese, there's no comma after it. Right? So even though that's the case, I still like to think of the comma as being attached at the sort of suffixed onto the end of an item, even though that we don't always do it. So Sam 67, 85.5 and true. Run. And now we get a tick automatically added to that task. Next. Empty lists. Aha, now this is one of the ways you can declare a variable. Remember that word declaration, meaning you're assigning something to it just to get it sort of up and running so that you can use the variable name later. Empty lists. A list doesn't have to contain anything. You can create an empty list like this. So you can have empty list and assign to it some empty square brackets. And you can do that with strings. You can have an empty set, an empty pair of speech marks. Why would we create an empty list? Well, usually it's because we're planning on filling it up later based on some other input. We'll talk about ways of filling up a list in the next exercise. Let's practice writing an empty list. Task 1. Create an empty list and call it my empty list. Don't put anything in the list yet. Okay, let's do that. So my empty list. Here we go. My empty underscore list. And we're just going to assign to it the square brackets, nothing inside the square brackets. Run, and we get a tick. I can close that box now and click next. And instead of next, I can do Alt and dot. So, and back is Alt and comma. So if I practice that, it's good to use shortcuts. and look for shortcuts and seek out keyboard shortcuts in whatever you're using. It's just a best practice. So if I do Alt, comma, we've gone next. If I do Alt, back. So you'll notice that the key on your keyboard with the comma and the full stop on are actually angle arrows. So the arrow pointing back takes you back, which is also the one that has a dot on it. So we've done that, so I'm going to go Alt, comma. As we start exploring lists further in the next exercises, we will encounter the concept of a method. Really important word, method. So let's explore that. In Python, for any specific data type, strings, booleans, lists, etc., there is built-in functionality that we can use to create and manipulate and even delete our data. Okay. In Python, for any specific data type, there is built-in functionality that we can use to create, manipulate, and even delete our data. We call this built-in functionality a method. So a method is the built-in functionality associated with a particular a particular data type, like a string, or a particular data type such as a boolean. For lists, methods, that built-in functionality, methods will follow the form of list name dot method and then some blanked out rounded brackets. Some methods will require an input value that will go between the parentheses of the method. So we have these rounded brackets and they take arguments. An example of a popular list method is .append, which allows us to add an element to the end of a list. Let's take a look at this code. Let's take a moment. So it says append example. Right, you can see that append underscore example. And then we have the assignment operator. So we're going to assign something to this variable. And we've assigned it a list to it. So we've got square brackets, this in single quotation marks, comma, is, comma, an example. So we have, let's get the terminology right. We have 4 objects, things, elements. I like to use the word elements. 4 elements in the list. They're using single quotation marks for each one, which means it's a string. And we have a total of 1, 2, 3 commas, just to act as dividers between the 4 elements. So that's append example. And then we do append example dot append, and we feed in some information into that method. So this is a method. So dot append, whenever you see dot something, it's a method, roughly speaking. And what gets printed, we then do the print function and we feed in the name of the variable, so append example, right? Append example is the name of the list, so we do the print function with append example. And what it does is it prints a list. So notice how it doesn't remove the square brackets. It doesn't just say, okay, here's your list, let me take it out the packet and just lay out the elements bare. No, it does actually just give you the whole list with the square brackets. But notice that there's a 5th element called list, and there wasn't a 5th element here when we assigned a value to append example. So obviously what's happened is we've used .append to add an item to the end of the list. Instructions. We will be exploring .append and many other methods in the upcoming exercises. But for now, take a second to examine and play around with the code for 2 common list methods. So it says example list, and we'll assign 1, 2, 3, 4, and we can do example list.append 5, and then we can print example list. So I'm going to uncomment that and do run, and we've got 1, 2, 3, 4, 5. You can see because we did the name of the list and then .append. We can also do remove, the remove method. So we can do the name of a list .remove, and you just feed in the thing that you want to remove. So I'm going to decomment this print line, and we should get a list printed which says 1, 2, 3, 4. Perfect. So we've got .append and .remove. No, go back again and use the keyboard shortcut. Alt, next. It's a habit. Previous, list methods, we've got .append and .remove. Alt, next. Growing a list, append. We can add a single element to a list using the .append Python method. Suppose we have an empty list called garden. So we'll say garden, and we'll assign to that variable these emptied out square brackets. We can add the element tomatoes by using the .append method. And notice how the plural of tomato is tomatoes, so toes. It's the same as the word which refers to multiple toes, like the digits on your feet, TOES. It does not become TOS at the end, TOS, it becomes TOES, that is correct. And if you're just talking about many tomatoes, you don't need to use an apostrophe. If I was saying, the tomato's redness is excellent, well then the redness belongs to the tomato, and then I'd think about using an apostrophe. But if I was saying, we sell tomatoes, if I were writing that on a chalkboard, it's we sell tomatoes, TOES, no apostrophe needed at all. So we can add the element, so we've got a blanked out list, we can add the element tomatoes, capital T, so the string, by using the .append method. So all we have to do is do garden.append, and you have to tell it what you want to add on. So you put in tomatoes into the rounded brackets, and then we can do print garden. And it will output tomatoes. We see that garden now contains tomatoes. When we use .append on a list that already has elements, our new element is added to the end of the list. So if we have garden and we assign to it this list, so tomatoes, grapes, cauliflower, we can append a new element. We can do garden.append and put in and feed in green beans, and then we can do print garden. And so, look, it originally had tomatoes, grapes, cauliflower. Now we've added green beans, so it'll print out tomato, grapes, cauliflower, and green beans. Let's use the .append method to manipulate a list. Instructions. Geo works for a gardening store called Petal Power. Geo keeps a record of orders in a list called orders. Use print to inspect the orders he has received today. So we can see here we have orders, and there are two elements in square brackets. Well, I can just do print orders. Thank you. And now that's got a tick. Geo just received a new order for tulips. TULIPS. 6 letters. TULIPS. Tulips are flowers. Use append to add this string to orders. So now I'm going to do orders dot append, and I need to feed in an argument. Remember, an argument is something intended to influence someone. In this case, it's some information intended to influence the way that the method works. So in what way do we want to add to the list? Well, specifically I want to add an item called tulips. So I put that in as my argument, and then I click run. Oh, and then if I were to print orders, it would now contain tulips as well as daisies and periwinkle. But I'm not going to add a print statement yet because it doesn't ask me to. It just says use append to add the string to orders. I click run and we get a tick. Another order has come in. Use append to add roses, R-O-S-E-S, to orders. So now I can do orders dot roses. So no, orders dot append roses. Run. Use print to inspect the orders Geo has received today. Now let's print it. Print orders. And now I get a list printed which has 4 elements: daisies, periwinkle, tulips, and roses. And I still have that print, the output from the other print function, which prints orders. Again, that's an important point. It's not the case that the order of the lines in the program matters. So this print function only considers the value assigned to orders in the preceding lines. So here it's got to print orders. The console has to print orders. It doesn't go. We could look at the value here. We could look at the value of orders by line 5. On line 3 and 4 we've changed it, so any print function takes what it knows at that point in the document. It's like, the order of lines matters. Okay, I'm going to go next now, so I'm going to do alt, comma. Growing a list, plus. When we want to add multiple items to a list, we can use plus to combine 2 lists, and this is also known as concatenation. Below we have a list of items sold at a bakery, and it's called items sold. So items sold has assigned to it cake, cookie, bread in square brackets. Suppose the bakery wants to start selling biscuit and tart. Singular, biscuit, tart. Items sold new, so we've not mentioned that before. So we have items sold, but we could have a variable called items sold new, and we'll assign to that items sold, this variable here, plus biscuit, comma, tart. So can you see what we're doing? We're naming a list. Items sold is the name of a list, and we're allowed to just say plus, and then add on another list. And if we do print items sold new, it will actually print cake, cookie, bread. So the original list, comma, biscuit, comma, tart. In this example, we created a new variable, items sold new, which contained both the original items sold and the new items. We can inspect the original items sold and see that it did not change. We can only use plus with other lists. If we try to run this code, so if we do my list, look, if we do my list and we assign to it 1, 2, 3 in square brackets, okay, you understand that, good. And then we do my new list, and we'll assign to my new list, my list plus 4. I mean, that looks sort of alright, doesn't it? We're adding 2 things together. You want another element in there. You say plus 4. You've named the element. Good. So what's gone wrong here? Well, we get a type error. The problem is you can't add bare elements. You have to add a whole list. You have to add the list package. We will get the following error. Type error. Can only concatenate lists, not integers, to the list. If we want to add a single element using plus, we have to put it into a list with brackets, square brackets. So you have to do my list plus and then in square brackets 4. So it has to be plus and then a square bracket package. Okay, now let's use plus to practice combining two lists. And also notice, something else I want to point out is just to stress it, that because this stuff, we started off by saying growing a list, and from that it sounds like it's not clear. Why do we need a new variable for that? We've got a list called orders here. So orders equals Daisy, Buttercup, Snapdragon, Gardenia, Lily, so 5 elements, and we want to grow it so that it also contains rows. I want to grow the list, so I might just do orders plus, I might just have a line where I do orders plus rows. And now I've grown the list. But you can't do that, or at least that's not what we've done here, is it? That's not what we're saying. What you do is there's this whole sort of practice of going, oh, new list, and then we'll assign to new. It's almost like you're reverse engineering it, and we assign to new list orders plus rows, and that is the way it's done. But I just want to make explicit something that you probably can have already implicitly noticed, which is that there's something strange about that. I mean, if you want to grow the list, your thought in your head goes like this. Start with orders, so you write orders first. You add what you want to add. So you certainly don't start by thinking new list equals. It's almost as if you have to write it in this way. You have to do orders plus rows. Oh, okay. And then write out the name of the new variable. So it's almost like I want to write the assignment lines backwards, or do the thing being assigned first, and then the name of the variable. You actually write the name of the variable later in time. Okay, instructions. Geo is updating a list of... Right, let's do alt, comma, and alt. Okay, where is the console? Okay, so alt, next. So, 1. Geo is updating a list of orders. He just received orders for Lilac and Iris. Create a new list. Sorry, create a list called new orders that contains our new orders. So there's a comment line here, so hash space create new orders here. So I'm going to call the new variable new underscore orders, right? ORDERS, and they say it needs to contain our new orders, and that's their way of saying we need to assign to it, because when you assign something to it, it's kind of in it. If a soldier gets assigned to a particular regiment, then they are sort of in it, aren't they? They're contained within it. So we assign to that variable, which is like the regiment, and we can build it from orders. So we use orders as our starting point, and then we'll say, so, no, orders, no, you don't need square brackets around the name of the list. The square brackets contain the elements. They aren't used to say that what we're talking about inside the square brackets is a list. So it's equal to orders plus, and then I do actually spell out the content of my list. Lilac, comma, and then Iris, IRIS. And I'm just going to print new orders, just for me to see it. Again, new orders is the name of a variable, so I don't need square brackets around it. Square brackets contain the elements of a list, but they don't go around the name of a list. So print new orders, good. I've got my new list, which is not just 5, but 7 items in it. See there? 1, 2, 3, 4, 5, 6, 7. Okay. 2, use plus, so I've got a tick by that now. And remove that print statement. Use plus to create a new list called orders combined that combines orders with new orders. Okay. Orders combined, that will have assigned to it the combination of orders, and so orders plus new orders. And now I've got a tick. 3. Remove the hash and white space in front of the broken pieces list. If you run this code, you'll get an error. It will say type error. Can only concatenate list to a list. You can't concatenate an integer, so they say you can only concatenate a list, not an integer to a list. Fix the command by inserting square brackets so that it will run without errors. So I click delete on the hash, and just moved it down to make it clearer to see. So if we see here, we've got 5, 3, 4, 4, 5, 4, and then we close the square bracket and we do plus 4. And the idea is, if we do run, we get this type error. See, it says type error, can only concatenate list to a list. What we're doing here is we're not concatenating a list, we're concatenating a numeric value. 4 is a numeric value, 4 isn't a list. So to fix this, we need to put that in square brackets, and now we don't get the type error. And if I were to print it, so I could do print broken pieces, broken prices rather, and I should get 1, 2, 3, 4, 5, 6 elements in this list that is printed. There we go. 1, 2, 3, 4, 5, 6. Now I'm going to go next, so I'm going to go Alt, comma. Accessing list elements. We are interviewing candidates for a job. We will call each candidate in order, represented by a Python list. Calls has assigned to it Juan, Zofia, Amare, Ezio, Ananya. So 5 elements in the list. First we'll call Juan, then Zofia, etc. In Python, we call the location of an element in a list its index. Now, just allow me a minute to explain why we use the word index here, because I want you to see that it is in alignment with the index that you're probably most familiar with, the index in a book. If you think about what an index in a book is, let's say the book is Nature's Birds by David Attenborough, and the index allows you to quickly search the book. So let's say, oh, we've just spotted a magpie in the garden. You don't want to read the book from front to the end. You want to check if magpie is mentioned on any pages. Now, if you go in the index, it has a series of words in alphabetical order. So a word beginning with A, then a word beginning with B, like beak, then a word beginning with C, like crane, and you go all the way down until you find magpie, and then it says page 7, page 32, page 52, meaning these are the pages where magpies are discussed or whatever. That's what an index in a book is, isn't it? So you can just go right to that page. That is real precision targeting of the book, of the book's contents. And So how is that related to what we're doing here? Because what we're doing here is we're saying we call the location of each element its index. So this is 0, 1, position 3, position 4, position 5. So these are 5 positions. 5 positions, and that position of the element, that property is called its index. Okay. Now, how does that relate to a book? I mean, put it into words. Well, so the page numbers in a book are like the positions here. That's the way I would put it. So this is like page 0, page 1, page 3, page 2, page 3, page 4. And so in a book, well, what is it? Because of course in a book Magpie has multiple page numbers, so it's not exactly right, is it? It's not a perfect analogy, because here it if index really is just position, then it only has 1. Juan is in position 0. It's not position. Juan is in. Well, it could be, actually. That's a good point. So could Juan be in position 0 and position 6? Right? Could we have a list which is calls? Let's see. Calls is equal to Juan. Come on, Juan. Oh my word! Come on. Juan, Juan, comma, Zofia, Zofia, comma, Amare, Amar, comma, Ezio, comma, Ananya. But could we then have comma, Juan again? And then we can do the print function. So if we print calls, let's just check the console. Yeah, I mean, we don't get an error. Yeah, Juan and Juan. There's nothing that says you can only have an element appear once. You can have a list which is Juan, 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 Juan. So how would that... And that's a really important point. When we make use of these positional properties with this list in Python, we don't start with the word. We don't say, okay, I'm interested in Juan. Where is Juan mentioned? And then Python comes back and says position 0 and position 5. It actually doesn't work like that. Actually, the information we provide is the position. So I might say what's in position 0, and it comes back with Juan. So it's important to get the directionality right. And with most of the time with an index in a book, you come to the book with a particular word in mind. So that's opposite to what we're doing here. That's different to what we're doing here. You come and say, I'm interested in Juan in this novel, or this, not novel, in this non-fiction book, this informational book. What pages is Juan mentioned on? So it comes back with page numbers. And in that case, we can just adjust the analogy a little bit to make it a bit more accurate. What the index in a book does is it maps these categories of the book Yeah, it maps the categories of the book where the categories are the pages, the page numbers, because a page number is just a way of referring to one of the sort of grid blocks of the book. And it's not a one-to-one mapping. It's not like Magpie is only mentioned on one page and no other pages. It's a many-to-one map. It's a many-to-many mapping, basically. So we might say page 5 might be an important page in the sense that this is where magpies are mentioned, it's where we talk about nests, and it's where we talk about bird eggs. And so actually, if you look at bird eggs, that will say go to page 5. If you look at magpie, that will say page 5. So page 5 is mentioned a lot. So but we'll also find that if you look at one particular word, like magpie, well, magpie is mentioned on page 5, yes, but also page 32 and 58. So it's a many-to-many mapping. One page number is mapped to many topics or words, and one word is matched to many page numbers. However, the words in the index, the pages at the back of the book, they're only written once. There's only one entry where you say magpie. Go to page 7 and 32 and 58. And so just as we can break up a book into sort of grid blocks, these regular spatial categories, which are the page numbers, page 1, page 2, page 3, in the same way we can break up a list into its constituent elements. So we have position 0, position 1, position 2, position 3, position 4. So these are like the page numbers of a book, the positions, right? Forget whatever content is here, whether position 0 contains Juan or Zofia or Fred or Ezio or whatever. This will always be position 0, just as with a book. Whatever book it is, there will always be a page 1. Yeah. Okay, I'm going to leave that for now. So first we'll call Juan, then Zofia, etc. In Python, we call the location of an element in a list its index. So they've said that an index is something that belongs to an element. It's a property of an element, meaning its location in the list. And I'm just going to say we don't talk about that with books. We don't say the index of magpie is page 5, 6, 32 and 58. Or do we? Do some people speak like that? Python lists are 0 indexed. This means that the first element in a list has an index of 0 rather than 1. So we go 0, 1, 2, 3, 4. We don't go 1, 2, 3. Here are the index numbers for the list calls. So we have one column for our elements. We have Juan, Zofia, Amare, Ezio, Ananya, and there's an index 0, 1, 2, 3, 4. So Juan has an index of 0, Zofia has an index of 1. In this example, the element with index 2 is Amare. We can select a single element from a list by using square brackets and the index of the list item. If we wanted to select the third item from the list, we'd use calls, and then we just go right into the square brackets and put 2. So calls, opening square bracket, 2, closing square bracket. So if I were to print calls 2, it will output Amare. Note: when accessing elements of a list, you must use an integer as the index. If you use a float, you will get an error. This can be especially tricky when using division. For example, if you do print and you do calls for/2, it will result in an error, because 4/2 gets evaluated to the float 2.0. Wow, that's really interesting. 4/2 becomes 2.0. Do you see what they're saying? There's nothing wrong with 4/2 inherently. It's not like there's something intrinsically wrong with 4/2, because it's a nice idea. You want 4 divided by 2 will evaluate to 2. It collapses down into 2, doesn't it? But it collapses down into 2.0. That's the problem. If it collapsed down into 2, the integer, that would be okay. To solve this problem, you can force the result of your division to be an integer, an int, by using the int function. The int function takes a number and cuts off the decimal point. For example, int and then feeding in 5.9 and int where we feed in 5.0 will both become 5. Therefore, if we do calls and we put in int 4/2, that will result in the same value as calls 2, whereas calls 4/2 will result in an error. Okay. Let's give ourselves some chance to understand this and do the instructions. Instructions. Use square brackets to access the 4th employee from the list employees. Now, when they say 4th employee, they must mean, the 4th employee. I mean, put it this way, they don't mean the employee in position 4, right? Because then we'd go 0, 0 if employee, 1st employee, 2nd employee. Presumably, when they say 4th employee, they're adopting this framework in which there is a 1st employee, but there is not a 0 if employee. So I'm going to assume 0, 1, 2, 3, that they want us to use the free position to get this thing that they refer to as the 4th employee. Does that make sense? Anyway, use square brackets to access the 4th employee, so from the list employees. Save it to the variable employee4. So look at the code. Give it a minute to speak to you. Well, we clearly on line 1, let's allow it to reconnect, have a list. Use the right terminology. It's a list, not an array, a list. It's not a dictionary, it's a list. It's called employees, Michael, Dwight, Jim, Pam, Ryan, Andy, Robert. So 7 things in that list. We've got another list called calls, Juan, Sophia, Amar, Ezio, Ananya, Juan, go away. So 6 things in that list. And we've got a print function which is printing the name of the list, and the list is called calls. And they're saying use square brackets to access the 4th employee from the list employees, so from this list. So I'm going to go and do a print function. Print function employees, and then square brackets, and I'm going to put 3 because I think they want me to print Pam. 1st employee, 2nd employee, 3rd employee, 4th employee. Run. Save it to the variable employee4. Okay, so what I need to do first is employee4. So that's another thing. Just notice the fact that that was my instinct. That's really interesting. That's the kind of thing I'm interested in. The first thing I do is just put the sort of grabber, that index expression. Okay, so we can call this an index expression. So we have the name of a list and then the specific position we're interested in. I put that in the print function, but what it wants me to do is first sort of abstract that out of the print function. So, and sort of package it up within employee4. So employee4, we can assign to employee4 employees 3, and now all we have to do is print employee 4. So there's this. So that is a practice, and I obviously didn't have it as an instinct, but that presumably we want to develop that instinct, this instinct of keeping it sort of all abstracted away. Put it in employee 4, then just refer to employee 4. I mean, it's the same thing effectively, but presumably there's some advantage to doing that, to having the print function just mention one variable name. And there we go, and we've got a tick. Paste the following code into script.py. So print employees 8. Okay, your wish is my command. Print employees 8. So what's this? That's an index expression, and it should get the 9th employee in employees. If I do, but of course there's only 7 employees in the employees list. So if I do print, we get an error because there's only 7 employees. And it says the error is on line 11, so the error is here with the print function, it's not with the list. That's interesting because it might say the list is too short and the error is there, but it says no, the error is with the list, with the print function. So it says line 11 in module. Well, we don't have modules dividing up our code, so it just says module in angle brackets. Print employee line 11. It says what you've got. It's not a type error, not a name error, not an not a syntax error, but an index error. The list index is out of range. That's because we've not got 8 items in our list, or rather 9 items, because 8 presumes there are 9 items. 0th, 1st, 8th. Accessing an element that does not exist produces an index error. In the line of code that you pasted, change 8 to an index that exists so that you don't get an index error. Well, I'm going to change it to 0th, 1, 2, 3, 4, 5, 6, 6. And that should work. Good, and we get back Robert. Again, notice that to get the 7th item, I use a number 6. That's a bit strange, but that's how it works. And we're going to leave it there. Next time we'll look at using a negative index.